Hey everyone, it's Justin again. This video's purpose is to help you check your work on the third problem in the additional practice section of your PDF for the Analyzing Functions Part 3 lesson. If you haven't worked through this as much as possible on your own first, pause the video and do so now. This example problem asks us to analyze the graph of the function to define the function's attributes using interval notation where applicable. Let's start with part A first. Since this function is represented by a single unbroken line, it is a continuous function. The domain includes all of these real numbers from -4 to positive infinity. We know this function continues on forever to positive infinity because of this arrow on the function. Our interval has a curved bracket with -4 because this open, not shaded endpoint tells us that -4 is not included in our interval. And we have a curved bracket with infinity since infinity is a concept rather than an actual number to include in an interval. As for the range, it includes all of these real numbers from 2 to -infinity. This arrow, once again, tells us the function will continue forever to -infinity. Writing this as an interval, we use a curved bracket since -infinity is a concept rather than an actual number to include, and a squared bracket to include 2 within the interval. The y-intercept for this function can be found here at 0, 0, where the function crosses the vertical y-axis. And as for the x-intercepts, they are found where the function crosses the horizontal x-axis, which happens to be in 2 places. Here at 0, 0, and here at 4, 0. Notice that the point 0, 0 is both a y and x-intercept. And that's because 0, 0 is a shared point where the x and y axis meet. Did you notice that we didn't include this point as an x-intercept? That's because the function doesn't actually cross the x-axis here, since this is an open, not shaded endpoint. Next up, we're looking for any intervals where the function is increasing. Reading our graph from left to right, we can see the function is increasing at this interval, which we can describe as all of the x values between -2 and 2. Since a function is never increasing or decreasing at the beginning and end of the interval, we use curved brackets here to indicate that -2 and 2 are not included in this interval. And finally, reading from left to right, looking for any intervals where the function is decreasing, we can find that these 2 intervals are decreasing and can be described as all of the x values between -4 and -2, and 2 and infinity. Again, since a function is never increasing or decreasing at the beginning and end of an interval, we use curved brackets here to indicate that -4, -2, 2, and infinity are not included in this interval. Nicely done. And thank you for checking your work with me. Remember, you can always come back to these help videos whenever you need.